BM-HeLP Implementation of Box Method in Solving HESS'S Law Problem. This project is led by a team of 6 members, and they are Muhammad Fazli Pauzi, Nur Azlan Ahmad Yaakob, Muhammad Shukri Zakaria, Muhammad Zikri Rashid, Nur Nasuha Hashim, and Tah Meiza. This project was initiated upon finding out students' concern regarding the topic HESS'S law. A student said how to arrange given equation into energy cycle correctly. Another student said, I don't see a clear steps to construct the energy cycle. Why are there certain molecules must be placed on the arrow? And the last one, there are too many information and I don't know where to begin. And these are some of the concerns shared by the students. These concerns shared by the students have sparked an innovation idea with a set of goals in mind. They are to improve the students' understanding in HESS'S law, and we would like to design a tool to enhance students' ability to construct the energy cycle. Apart from that, we would like to enhance students' understanding and increase their score in the construction of energy cycle. The implementation phase. We started the initial development through collaborative discussion held in a peer learning community settings, which then was employed and tested to a group of students. Further steps were taken after some careful improvisation afterwards, and that brings us to where we are currently. The improved version of the technique was shared through sharing sessions with other matriculation colleges. The timeline. We started the project from August 2020, where we discussed students' reflections on constructing the energy cycle. In September, box method was introduced and tested within the PLC group. In the following month, some discussions were done to identify the strengths and weaknesses of the method. All through to November, some improvisation was done to polish the technique. This polished version then was tested among students in January, and this is followed by a reporting process which is done in February. The first edition of box method was implemented via 2 stages. The first phase is where the basic of HESS'S law and how to construct energy cycle using traditional method were explained. Then, the 3-box visual aid that underpins the box method was introduced. The HESS'S law. HESS'S law states that in order for the reactant to convert into a product, the enthalpy change is the same whether it takes 1 step or more than 1 steps. And this is described in the figure 1 as shown here. By referring to this example, A is the reactant whilst B is the product. Suppose we want to find out the value of enthalpy, which is delta H1, from A to B. This can be calculated via alternative pathway from A to C, then C to B, whereby the enthalpy H2, delta H2, and delta H3 are summed up together. This is the problem where students had, where they were struggling on how to construct this cycle. This brings us to the box method. This is how a box method is typically constructed, where we have a box of reactants and a box of products and a box for other things here, where the top boxes are the target equation. The instructions for box method in the first edition have 7 steps. The first step is to draw 3 boxes, then fill the boxes with target equation, and if there are 2 reactants, just focus on 1 reactant, and then the students have to draw arrows, and then they have to fill in the enthalpy change with the correct value, and then they have to focus on the large box at the bottom and choose one of the components, and then they had to draw another arrow connecting the large box to the product box. These steps were confusing at first, so we come up with the second edition through a process of discussions. The second edition with added value, the box method. The students were given a step-by-step guide which is perfected to a shorter and concise 6 steps version. An acronym for steps are introduced in order to improve students' retention of the steps, and visual aid and animated steps are also prepared to promote self-learning by using PowerPoint. The acronym for this step is ACFAT. A for adjust equation, C for construct boxes, F for fill target equation, A for assemble each equation, A for adjust arrow, and T for total up enthalpies. This is how the box method can be employed. The following is the question sample. Let's watch the steps together. These are some of the pictures of the implementation of box method in a classroom. And the following are some of the students' work. These are some of the students' review after implementing the box method in a classroom. And this method was shared to other colleges as well. One in Pahang, Engineering Matriculation College, and another one in Johor Matriculation College. The effectiveness of this method, construct energy cycle. So from this data, we can see that students have improved their performance with constructing energy cycle after the implementation of the method. By using effect size analysis, we can see that this method has a large effect size of 2.485. By implementing the box method, students' achievement have improved, whereby 94% of the students involved in the pre and post test have improved their performance, whereby 6% of the students have an unchanged performance, and none of the students had worsened their ability in constructing the energy cycle. And these are the students' perception with the box method. Generally speaking, most students agree that the method is helpful for them in order to learn HESS'S law. This project has been registered for copyright with my IPO. In conclusion, students' understanding towards HESS'S law increased after intervention using BM-HeLP, and students' score increased significantly after intervention by using BM-HeLP on constructing energy cycle. That is all. Thank you.